Hey everybody, how's it going? If you skipped the last video, honestly don't worry about it, that's okay. Today we're going to adapt the generate data function for more parameters, like in multiple linear regression. So we're just going to copy in this function for generate data and look at it here. So what were we doing before? Well, we don't need matplotlib right now, so don't worry about that. What were we doing before? Well, we were given some parameters, which I'm going to switch that into beta and not worry about collecting each beta naught and beta 1, and we'll fix down here later. So we have a big long beta vector like this. We were given an x lower and an x upper, which basically specified here, where we said, okay, it looks like the x lower was -2, the x upper was around 3 here, and so we got data that was in this range. Now, we can't really specify just one x lower and one x upper. We have to specify this for each of the predictor x variables. So for x1, the first predictor, we need an x lower and an x upper. And so actually, we're going to change this into just an x matrix. Okay, so this is going to be x range, I'll call it, which is basically the first column is going to be each of the lower bounds for each of the x's, and the second column is going to be each of the upper bounds, so that each row is basically what we had before. Each row is one of these pairs of lower and upper. I hope that made sense. Writing this function is actually a little bit confusing and a solid exercise in NumPy, but what I'm going to do is write it for you, and then I'm going to explain each line afterwards to take it step by step instead of fighting around with it with you. Okay, now really don't worry too much about understanding everything here. It's not a big deal, but try to listen to me here and get some pieces of it. So what we want back, and this is only half the function for now, what we want back is something that looks like a random design matrix. So here, the first column is going to be entirely ones, and that makes sense. The second column is going to be all in some specific range. So this is according to x1 or x2, whatever you want to call it. It's the first actual predictor variable, and we want all of these values to be in some range that we specify. And we specified that by right here. I said, give me random values between 1 and 3. The last column here, I said, give me random values between 2 and 3. So we can give it this range, where as long as we have the first thing saying this is only going to be ones, and then afterwards we can say each of these, give me this range and this range, then we can specify with this function here. Don't worry about the syntax too much. We're actually importing something called numpy.random.uniform. And so if we get the lows, which is all of this first column here, those are all the lows, and then the highs are this second column right here, that we can let x be the numpy.random.uniform, where we set the low equal to the lows, and so that's actually a vector of lows. We set the high equal to the highs, that's the vector of highs. And then if we specify that the size is going to be n, so this part's variable, where we have, say, however many we want, I specified that we want 10 results back. We could have got just 1 or 2 or 20. And then, so n by p, so we're saying p because that is the number of things that we have here. Okay, so it's kind of confusing, and it honestly kind of confused me too, but that's the main idea. And so up here, half of our function, which just returns a random design matrix, we're going to get the lows to be x range, which is the first column, highs is x range, which is the second column, and then x random is that same thing down below. So if this is our random design matrix, we have to get random y values associated with this, and we're assuming there's some sort of underlying pattern here that is linear. That is, there exists some true beta naught, beta 1, and beta 2 in this example, such that the actual y value should be beta naught times this, plus beta 1 times this, plus beta 2 times this. And the y value for this should be beta naught times this, plus beta 1 times this, plus beta 2 times this. Okay, so there's some true underlying relationship there, which I'm going to call true beta. We have to define that if we're making random data. So we have this random design matrix here. To get the actual y value, well, you could probably guess that it's actually going to be the matrix vector multiplication, very similar to above with the y hat function. It's going to be the matrix multiplication of this matrix and the true beta vector. And so we can multiply that down and see that this would be the actual proper y value for this. This would be the proper y value for this, and so on. So now if we get that, that is stuck in numpy ... of x and true beta. But that would be the actual super proper answer And so that would mean that our answers would follow properly in a true, you can kind of think about it's still a line. It's, more than 3-dimensional. This one is, 3 or 4-dimensional. So it's hard to graph it at this point, but it would still fall in some particular line. We actually start to call it a hyperplane at this point, but still think about it. It would fall perfectly in a line, and we don't want that. And so what we do is we add n random values. Again, it shouldn't actually be a uniform distribution. We might talk about that later. It should be a normal distribution. But what we do is add some noise or error so that it doesn't fall perfectly in a line. And so we're going to end up with y is the matrix multiplication of this design matrix with the true underlying beta. So that gives our proper answer for each of them. But then we get errors as well. And if I add that into our function, what we have up here is y random is that exact same thing plus the error, and then we're just going to return x random and y random. And again, if you didn't catch all of that, really not a big deal. The point is we're using NumPy to make some random data. And actually, just to be explicitly clear, I should be changing this to true beta because that's really the true underlying relationship here. So I'm going to change that in every location, and it's only going to be there as the final one.